Hello everyone, I hope all of you are having a wonderful time. So today is 27th of October and we are in chapter number 11, dual nature of radiation and matter. So the chapter talks about dual nature, double characteristic of what? Of radiation of matter. Now whenever we talk about radiation, we talk about electromagnetic waves, okay? Now you know that light is an electromagnetic wave, right? So now you studied about light as a wave in chapter number 10, that is wave optics. All right. So light is a electromagnetic wave, or light is a wave. Now in this chapter you will also see that light behaves as a particle as well in the topic called photoelectric effect. We'll see that. Next, matter. When you talk about matter, you talk about electrons, you talk about protons, you talk about neutrons, you talk about atoms. Now we consider these particles to be what? To be matter, okay, or you consider them to be as particles. Now when you talk about particles, you are taking them as matter, right? Now in this chapter we'll see they also behave as waves, all right, under the topic called de Broglie wave, or de Broglie wave, or de Broglie hypothesis. All right, so this is the syllabus suggested by CBSE, okay, and this is my contact name and address. So firstly we'll understand what is a photon. Now you understand energy, right? So a packet of energy, a packet of bundle of energy is called photon. A packet of energy, basically light energy you should say, a packet of light energy is called photon, okay. Now the energy of a photon is given by E equals to h nu, and that is equal to, because nu is frequency, h is Planck's constant, so nu equals what? Nu equals c by lambda. All right, so here nu is the frequency of the photon, lambda is the wavelength of the photon, and h is your Planck's constant, whose value is 6.6 into 10 to the power minus 34 joule second. In electron volt second unit, it gives you what? It gives you 4.14 into 10 to the power minus 15 electron volt second, okay. Now how do you convert say joule to electron volt? Okay, you will multiply the number, sorry, I'm making a mistake. You'll divide the number, okay, that was for electron volt to joule. You'll divide the number by the value of E, by E. What is the value of E? E is 1.6 into 10 to the power minus 19 coulomb, right? Now when you have to convert electron volt to joule, you multiply by value of E, okay. So here what we have done, we have divided this number by 1.6 into 10 to the power minus 19 to get this. So you have converted that into electron volt second. Now we'll see the properties of photon, okay. Now number one, photon travels with the speed of light, which is 3 into 10 to the power 8 meter per second, okay. Now to realize how fast is this speed, if you just convert it into kilometer, it will give you 3 into 10 to the power 5 kilometer per second. Now 10 to the power 5 means 1 lakh. All right, so it is telling you that light travels with the speed, or photon travels with the speed of 3 lakh kilometer in 1 second. That means with a blink of an eye, photon has traveled 3 lakh kilometer, okay. Now also you need to know that c is equal to nu lambda, from the relation nu equal to c by lambda, where nu is the frequency of the photon and lambda is the wavelength of the photon. So that is your property number A. Property number B is photon do not possess any charge, okay. Photon does not have charge, that you know very well, okay, and therefore it is not affected by or deflected by electric and magnetic fields. Photon has no charge, okay, therefore not affected, or rather you write down deflected, not deflected by electric and magnetic fields, okay. E indicates electric field, B indicates magnetic field. So So that is number B. Number C, photon has momentum given by P equal to h by lambda, and you can also write it as E by C. So this is a relation you'll remember. Momentum of a photon is given by P equals to h by lambda equals to E by C. Number D, now all photons will have a certain frequency, right? And you can consider like different photons having same frequency will have the same momentum. Okay, so that you very well understand by this point. Okay, when you have same frequency matlab same wavelength will be there. Okay, same frequency matlab same energy will be there. So under that situation, since C and H are constant, you'll have P value same. Okay, so when nu is constant for different photons, then P also remains constant for them. We can write that. Now point number E, rest mass of a photon is 0. Rest mass, or you can write down rest mass. Okay, rest mass is 0. What it means is you will never find a photon at rest in the entire universe. Okay, so relativistic mass or effective mass, where we call relativistic mass is given by the relation m equal to E by C square, and that is h nu by C square. So a certain photon of certain frequency will have a certain mass that can be calculated. Once you know the frequency, you can calculate the effective mass or the relativistic mass of a photon. So like these are the properties of photon. Now we come to the definition of electron volt, 1 eV. Okay, this is what electron volt. This is one more unit of energy. All right, so now when you tell like energy of a photon or energy of an electron is 1 electron volt. Say you have a metal plate and you have these electrons. Okay, and you apply plus 1 volt voltage here. Now plus 1 volt, since this is V value is what, 1 volt, plus 1 volt. And what is the charge here? Charge is E. Now we know work done is equal to QV. We have this relation. So under that situation, here the charge is E into 1 volt, so it becomes 1 eV. That means if you go by definition, when you accelerate an electron by a potential difference of 1 volt plus 1 volt, then the amount of energy possessed by the electron is 1 electron volt. Okay, so this is the amount of energy possessed by the electron. All right, so by this understanding, we'll find out the energy of a photon in electron volt. Energy of a photon in electron volt. Okay, so the relation is E equals to hc by lambda. So you see, value of h is 6.6 into 10 to the power minus 34. Value of c is 3 into 10 to the power 8 divided by value of lambda. Lambda will stay as it is. Now this calculation will get you the result in joule. Okay, now if I divide this 6.6 into 10 to the power minus 34 multiplied by 3 into 10 to the power 8, and I divide this by the value of E to convert into electron volt, 1.6 into 10 to the power minus 19 lambda. So this becomes electron volt. So this calculation will roughly give you 1240 into 10 to the power minus 9 by lambda electron volt. Now you have to remember this relation. This is very helpful while doing questions. Okay, when you have to find out the energy of a photon in electron volt directly, not in joule. Okay, you'll be using this when wavelength is given in meter and you want to find out the value of the energy in electron volt. Okay, now we have a couple of questions. All right, let me show you some questions based on this. I'll share the file. I'll share the standard file via WhatsApp groups. So in case you are interested, you can WhatsApp me in the number provided in the opening page. Now you see, what is the energy associated in joules with a photon of wavelength 4000 angstrom. Now wavelength is given as 4000 angstrom. Now 1 angstrom, what is the value? It is 10 to the power minus 10 meter, right? So 4000 angstrom will have that as a 4 into 10 to the power minus 7 meter. Okay. So if you want to find out the energy in joule, then you'll put hc by lambda. Value of h you'll use as 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 for the value of c, and you have 4 into 10 to the power minus 7, okay, for the value of lambda. Now these on calculation will get you will cross check the calculation later on, into 10 to the power minus 19 joule. Okay, the same thing can be done in electron volt also. How would you do that? In that case, you'll take lambda, which is 4000 angstrom, which is given as 4000 angstrom. You take that as 400 into 10 to the power minus 9 meter, okay, or 400 nanometer basically. So E equal to, we'll be using that relation, 1240 into 10 to the power minus 9 divided by lambda value is 400 into 10 to the power minus 9. Now your answer will be in electron volt directly. Okay, so 1240 divided by 400 will get you how much? 3.1 electron volt. Is that clear? So this is the result in electron volt, this is the result in joule, whichever or whatever is asked in the question. If they specify precisely, if they specify that find out the answer in joules, then you'll be doing the first part. If they tell you find the answer in electron volt, you'll be doing the second part. Of course, you can also convert this value in joule into electron volt. How? By dividing by 1.6 into 10 to the power minus 19. In that case also, you'll be getting the same result. So we have question number 2. So question number 2. So obtain the energy in joules acquired by an electron beam when accelerated through a potential difference of 2000 volt. So potential difference is 2000 volt, which is actually 2 into 10 to the power 3 volt. Now if potential difference is that much, you are asked to find out the energy in joule. So work done, which will be equal to kinetic energy, possessed by the, or energy like possessed by the electron, moving electron, right? And that will be equal to qv. Qv is, since the charges are electron here, so we'll put E in place of Q, and this gives you the value. Once you put the value of V, that is 2 into 10 to the power 3, well, 2000 electron volt is your answer, right? Now if you want to convert that in joule, so 2 into 10 to the power 3 into 1.6 into 10 to the power minus 19 joule, so that will give you 3.2 into 10 to the power minus 16 joule. So that's your answer. So that is question number 2. Number 3. So you see, monochromatic light of wavelength 6 into 10 to the power 14 hertz is produced by a laser. Okay, the power emitted by the laser is this. Now, what is the energy of the photon in the light beam and how many photons are emitted per second on an average, okay, by the source? Now you see, the laser is producing monochromatic light whose frequency is given. So from the frequency you can find out the energy very easily by using the relation h nu, right? So h value is 6.6 into 10 to the power minus 34, and what is the value of nu? It is 6 into 10 to the power 14. So once you do this calculation, how much would you get? 39.6 into 10 to the power minus 20, and that will get you 3.96 into 10 to the power minus 19 joule. So that is the value of energy. Okay, so we have calculated the energy part. Now the second part, what is asked, like how many photons will be emitted per second? Okay, how many photons will be emitted by the source per second? Now for one photon, now since the power is given, you see power is given in the question. Okay, so since power is given, what is the value? P equal to 2 into 10 to the power minus 3 watt. So for one photon, your energy relation is E equal to P into T, right? A relation of relation for energy with power. Okay, so for n photon it will be Ne equal to P into T, right? So we need to find out the number where n is the number of photon, right? So you need to find out the number of photons emitted per second. So n by T it is, which you are finding out. So n by T equal to P by E. What is the value of P given? 2 into 10 to the power minus 3. And what is the value of E that you've calculated in the first part? 3.96 into 10 to the power minus 19. Okay, so that gives you a value of 0.5 into 10 to the power 16. Okay, all the calculations you need to do it by yourself. Never work on a calculator. You will spoil your calculation skills. Okay, doesn't matter, it takes more time, doesn't really matter. Now you're learning. You will do all the calculations by yourself on the right part of the page. So this gives you 5 into 10 to the power 15 photons per second. Okay, so this is your answer. Next we see question number 4. So what is the question saying? The momentum of a photon is this, right? Find the wavelength and frequency associated with the photon. Now momentum is given as 3 into 10 to the power minus 29 kg meter per second. Now you have to find out the wavelength and frequency. Okay, so for momentum we have this relation P equal to h by lambda. So h equal to h by P you are doing, right? What is the value of h? 6.6 into 10 to the power minus 34 joule second. And what is the value of lambda? What is the value of P given in the question? 3 into 10 to the power minus 29, right? So on calculation this gets you 2.2 into 10 to the power minus 5 meter. So this is your answer for wavelength. Okay, so that's what you're finding out. No, you're also finding out frequency. So also nu equal to c by lambda. C value is how much? 3 into 10 to the power 8 meter per second, right? Speed of light. And what is the value of lambda? 2.2 into 10 to the power minus 5, right? So you do the calculation and you get 1.36 into 10 to the power into 10 to the power 13 hertz. So this is the answer for the second part. Let's see the next question. I hope you are understanding. Whatever you don't understand, you revisit the particular topic, and in case after going through again, if you still have doubts, you can text me, you can WhatsApp me in the given number. And in case you do not understand my handwriting, okay, so in that case also you can WhatsApp me, and I share the notes via the WhatsApp groups. So a photon possesses an energy of energy value of 1.5 mega electron volt, right? So what is the value of energy given? 1.5 MeV. Now you have mega. First of all, mega matlab kya hai? You have 10 to the power 6 for mega, right? And you convert it into joule by multiplying it with the value of E, right? So 1.5 into 10 to the power 6 for the mega thing into 1.6 into 10 to the power minus 19 for conversion into joule, right? So this calculation will get you 2.4 into 10 to the power minus 13 joule. Now what you're finding is momentum. So momentum is E by C, P equal to E by C. We had one relation. So E value is 2.4 into 10 to the power minus 13, and C value is 3 into 10 to the power 8, right? So in calculation this will get you how much? Like 24 by 3 into 10 to the power minus 14 minus 8. Okay, so that gets you 8 into 10 to the power minus 22 kg meter per second. So that's your answer. So we have a couple of homework problems. You'll go through them and I'll share the solution via the WhatsApp groups. Okay, I won't include the explanation of this in the next video. In case you have doubts, in case you have requests, then I will. Otherwise I'll pass to the next topic. Okay, of course you'll get the solution via WhatsApp groups in PDF format. And I hope going through the solutions it should be clear. The confusions, there should remain no confusions. Okay, so signing off for today. Thank you so much.